Hello, everyone, and welcome back from winter break. Last quarter, during our intern training, what we talked about was how we could make the basics of websites and how to show them to other people on the web. And last quarter, we talked a little bit about how to make static websites using tools like HTML and CSS, as well as how we could use tools like Git and GitHub in order to collaborate with others, as well as showcase our projects to the world. Well, this quarter, we're going to talk a little bit about how if HTML and CSS were able to make static websites, we're going to talk a little bit about how we can use scripting languages like JavaScript in order to make dynamic websites and try to see what the difference is between static and dynamic websites. All right, in that case, first, let's talk a little bit about what exactly is JavaScript. Well, as you can see here, it says here that JavaScript is interpreted scripting and programming language that is used within web applications. 1 second. And so first, let's take a look and see where can we see JavaScript inside of a page. If you go to google.com and you see like, oh, see what the console is, you can see that you can run JavaScript here. There's something small like console.log hello. And then we can see that it spits back at us. And what exactly JavaScript is, as we said, it's something that runs in a bunch of different browsers. And if we want to write JavaScript within some of our code, we can do that really simply by just adding a script tag within HTML. So to showcase this, let's go make a small little HTML file and call this like example.html. And we just do the boom in order to get like the basics of the HTML web page. And what we can add is that inside of our body tag, why don't we just add a little script? First, let's say hello inside of an H1. And let's go take a look and see what our page looks like by pulling it up inside of our Finder like last time. And if we go to ACM and we look at example.html, we can see it says hello on the top. And looking up at the console, we see that we don't see anything yet inside of our console. However, if we want to add in something cool, like let's do console.log hello world. And what the console is that it is basically an object inside JavaScript that lets us communicate with things in our browser or with a debugging application. And if we save this here, and if we go to our page and refresh, we can see that when we do this, we see on the top in our console, it says, hello world. And that's great. So with this example, we can see how JS is really similar to HTML and CSS in the fact that we can add them into any website we want to in order to do some really cool things. And if you don't want to simply like have a script tag here and you don't want to clutter up your HTML code, well, something else you can do is that you can simply make another file. Like in this case, why don't we call it scripts.js? And what we can do is that we can add in our script inside here, like so, console.log hello world. And if we want to be able to add in our script into our tag, we can just add like script source equals, and using this, we can just grab our scripts.js from within our file directory and load it to run. And we can see that if we refresh the page, okay, it is not showing up. Let's see, do we need to add it into 1 second? Is it loading? Question mark. Let's see.
So that red line is that.
Is there a red line? Let's see. Let's do some debugging and see what is happening right now. Close the script tag. And let's see. Okay, there we go. Looks like something that we learned the hard way is that we can't do a self-closing tag for the script, but what we can do is that we can just close it right away in order to get our script to run, like so. All right, now that we've done a little bit about how we can use JS in this example, what we're going to talk a little bit now is how exactly can we use JS as a programming language and other things. So real quick, I want to ask, who here has used a programming language like C or C++ before? You can just like raise your hand in the chat. Yeah, so for most people who have used things like C or C++, we can see that there are a few little differences or quirks to JavaScript that make it different. And today, let's take a look to see what exactly those differences are and look at our scripts.js. So a big part of a programming language is making a variable in order to do things. So like, let's say, for instance, we want to make a variable using our message. And the way we can do that is we can say var or message equals hello world. And if we want to run our message, what we can do is that if we want to say what our message is, instead of putting the string directly, we can put console.log message. And if we want to refresh our page, we can see it says here, hello world. So for people who have used other programming languages like C or C++ before, does anyone see any differences between how we made variables in JavaScript as opposed to those different programming languages?
You didn't include the type, right?
Yeah. So what we can see is that in JavaScript, when we're making a variable, we don't have to say the type of the thing, the type of the variable that we made. And oh, real quick, if you don't like having to refresh a page every time you make a change to your JS file, we can actually use something called Node to run our JavaScript files. And what Node is that it is a JavaScript runtime that allows us to basically run JavaScript files that we want to without having to use our browser. And if you don't have Node, you can install it with NVM. And we have a whole write-up on how you can install Node and get set up on your machine here. And in the future, if you want to, you can just take a look here and see how you can get Node running on your machine. And if you have Node installed, something you could simply say is that, let's say node scripts.js. And we can see that we can run the file that we want to without having to make and refresh our browser to run JavaScript files. And okay, now that we've talked a little bit about how we can run our JavaScript files, let's go back and see our message that we have here. As Jason said, with variables in JavaScript, you don't have to declare the type that they are. Well, that doesn't mean that there are no types though in JavaScript. Like for instance, if we want to see what the type is of our message, let's go here and let's see what shows up. If we console.log type of message for node scripts.js, node scripts.js, you can see that it says that our message is of type string. And this brings up another point, which is the different types that there are within JavaScript. And within JavaScript, there are basically two ways that data can be broken into. And they are basically primitives and objects. And what this type of does is that it tells you whether or not the thing that you are finding the type of, if it's one of those primitives, or if it is in fact an object. So let's take a look and see what are the different types of things within JavaScript. We have strings, we have numbers, we have big int, which as the name implies is a big integer. We have booleans, we have null, and finally, we also have undefined. And these are all different primitives within JavaScript. And we can see that even though we have not specifically said the type of the message to be like string message equals, what JavaScript is able to do is that as a dynamically typed language, which means that at runtime, it tries to determine what the type of everything is. It tries assigning the type of what every variable is or every data as it's running the code line by line, which means that things don't exactly have to be like, always the same type. Like for instance, if we want to say message equals 4, we can do that as well. And if we console.log message along with the type of the message, we can see that when we run scripts.js, we're able to do the same thing as well, which means that inside JavaScript, you don't have to be constrained to the specific type of something. You can change what it is as well. And this thing of typing goes into another fun, quirky thing you can do with JavaScript. Like, let's say, for instance, let's go into equality. And you know how in other programming languages, like if you've taken C++ and CS31 before, what you can do is that you can use the double equal sign to see if two things are equal. So let's say we have our message becoming 4 here. And real quick, okay, before we go on to this, let me backtrack a bit. And do you see how we have this let message equals hello world? Well, something else in JavaScript is that there are multiple different ways to declare variables. Before, we could use var in order to say like, oh, message equals hi. And you can also use something called const, message equals hi. And basically, what these 3 different ways are of making different variables is that first, var was the only old way to make a variable in JavaScript. And we're not going to go into this right now. We'll go into this later, but it uses something called global scoping in order to determine whether or not the object exists, while const and let were new and introduced in 2015 in JavaScript, and they use something called block scoping, which gives us the behavior that normally we like within our languages. Well, for instance, actually, let's go and take a look at the difference between block and global scoping right now with a little test example. Let's make an if statement right here. If true, which always gets made, let's go and say var word equals bird. And if we try console.logging word, let's see what happens. So in other programming languages like C or C++, do you guys know what the intended behavior of this would be?
It would give an error, right? Because word isn't defined in the next block.
Exactly, because in other languages, when you make a variable, you can only get to see what it is like within the scope of the block or the curly braces that it's made in. However, if we run our code, we can see that bird is in fact still there. However, if we use one of the block scope variables like let or const, we can see that when we run it, it says here, reference error, word is not defined. So while there are in fact like multiple or 3 different multiple ways to say like what you want a variable to be, we say that instead of saying var, it's better to use let or const, because those are the behavior of variables that we normally are familiar with, where you can only access them from within the scope of the block where they are made. And finally, that brings us to what is const. And as the word suggests, what const is that you cannot change the value that it points to. Like for instance, if we want to change the word to be 42 instead, we can see that if we run scripts.js, it says here, no, you cannot do that. You cannot have assignment to a constant variable. So essentially what const is that it tells you that once you have set the value of something, you cannot change the value that it points to. Do you have any questions on the difference between the three different ways you can assign variables in JavaScript? All right, perfect. In that case, then we're going to move on to equality. And let's go and remove all this stuff here. And let's go back into equality. Let's say that we have let number equal 42. And something we want to do now is that we want to say if the number equals 42, print or console.log equal. And let's try doing that and see what happens. It says here that number equals 42 works. And as we know, there are a lot of different types within JavaScript. So let's say that if we, instead of using the number 42, what if we compared it to the string 42? Do you guys think that this will be equal, or do you think that it'll not be equal? Anyone want to take a stab at it? I'm going to press the button. All right, I'm going to press the button. Let's see what happens if we say if the number 42 is equal to the string 42. It says here they are in fact equal. And that's a bit weird because we don't think that the number 42 is equal to the string 42 because they're different types. Well, something you can do in JavaScript is that it does something called type coercion, which means that if you do double equals and two things that you're comparing are of different types, they try to convert them to the same type of each other in order to do the equality operation. So in this case, what it does is that it takes the number 42 and tries converting it into the string 42 for equality. And if you don't like that, and if you really want things to be like, hey, I only want the string 42 to be equal to the string 42, then something you can do is that you can use the triple equal sign. And what the triple equal sign in JavaScript tells us is, like if we run here, it says that 42 is not equal to the number 42. And the reason for that is because triple equals in JavaScript does not do type coercion, and it checks to see if they're the equal value and they're of the same type as well. Do you have any questions on type coercion within JavaScript? Nice. In that case, we'll go a little bit more into type coercion to see how some things can work, like adding and subtracting. Like for instance, let's say we have the number 42 here. And then if we wanted to console.log the number or 42 plus hello, then what do you guys think will happen? Will it yell at us? Do you think it'll try doing something? What do you guys think? I think my intuition of C and C++ tell me that it's not going to let me try to add these two different things because they're of different type. And let's see what happens. When we run this, we can see that it actually does let us do that because within JavaScript, it does the exact same thing that we talked about, type coercion, as earlier. What it does is that it gets the number 42 and tries converting it into a string. And what it does is that it makes it so that it does everything in its power to make sure that you can, in fact, concatenate them. And by turning it into a string, you can actually console.log the number 42. All right. So this was a little bit about variables and types within JavaScript. And like as we said before, the important thing to note is that when you're saying variables, you don't have to specify the type of the variable. However, what you can see is that they still have types when you run type of, but what you can see is that JavaScript does some type coercion, and while it doesn't have variables that are statically typed, they are in fact dynamically typed and evaluated at runtime. All right, now that we talked a little bit about the data within the primitives, now let's talk about the whole other type of data that you can have within JavaScript. And the way that this is called, everything else that is not a primitive is actually called an object. And if we want to see how we can make an object, we can see that the notation to make an object in JavaScript is like so. Let's say we have a name. Let's make a dog, for instance. The dog has a name of Rufus and it has a breed of Border Collie. And let's see what exactly an object is in JavaScript. And what an object is that it's anything that is not one of these types. That string, number, begin, Boolean, null, or undefined. In fact, there are some other data structures from other programming languages that you might know as well. Like if this is an object, we can also have dog array of like, let's have Marty and McFly in an array. And what this is that this is also perchance an object in JavaScript. And with this notation of the first object we made here, what we see is that on the left side, we have the property of our object. And on the right side, we have the value that's associated with that property. If we want to go in and see what the value is of a property of an object, we can use the dot operator to be like, oh, I want to see what the name is of my dog with console.log dog.name or console.log dog.breed. And let's see what it tells us. Nodescripts.js. It tells us how Rufus is, in fact, a border collie. It's Rufus and a border collie. And if you try accessing, you can also access properties using the index of an object operator to get the breed of a dog. And you can also try getting something that doesn't exist. If you try getting a property of an object that doesn't exist, let's see what it tells us. If you run this code, it tells us how this section here of dog dot something that doesn't exist returns us undefined. So for a difference of like, objects versus primitives in JavaScript, there is another thing that we can do that helps outline the difference. So let's say we have our number be 42. And what we want to do now is that we have num copy number equal number. And then we change number to be 50. And then if number equals copy number, then we print out equal. Do you guys think that in this case, number and copy number are going to be equal? Or will they change because we've changed the value of number? Does anyone have any guess? All right, in that case, then let's try and node scripts.js and let's see what happens. It says that they're not in fact equal. And let's see, why is that the case? Let's first console.log what number is and say like, oh, number is, and let's say what copy number is. And let's take a look-see. Well, it says here number is 50 and copy number is 42. And to see a deeper look of how exactly this works, what we have to see is how does the assignment operator work in JavaScript? Well, what the assignment operator does is that it takes the value that's associated with number, like in this case, number is 42, and it gives it the copy number. If you want to take a look at how this looks like in memory, we can take a look at this nice little chart up here, which is here. 1 second. Yeah, Like with this chart here, with a similar example, where when you made numRef equal to myNum, if myNum had the value of 42 in our example here, what numRef does is that it takes the value associated with it and puts it inside of numRef. So when we change the value of myNum in the future, numRef doesn't change as well. Well, that's cool and all for primitives, but for objects, the behavior is actually slightly different. And let's see what that is. If, for instance, instead of using number, let's make numbers. Const numbers equals 1, 2, 3, and be like numbers copy equal numbers. And this is going to be a bit weird, but I'm going to explain what exactly is happening in a bit. Let's say that we change numbers index 0 to be 10, and let's console.log numbers and numbers copy. And let's see what exactly they print out at us. Looks like numbers is 1023 and numbers copy is 1023 as well. Right off the bat, does anyone see something a little fishy with what we've just done right here? Maybe something with this keyword here with const and changing things.
Numbers changed even though it was const.
Exactly. It looks like even though we've set the value of numbers to be a constant, we were still able to change the value of numbers index 0 to be 10 instead. And what we saw in the first place, where if you change numbers, numbers copy didn't change. And let's see how we were able to change the value of a const and why numbers copy changed as well. And the reason for this is actually because of something called references in JavaScript, which are similar to something called pointers in C and C++. So if you want to see references in JavaScript, the way that values are stored for objects, and in this case, an array is an object, is that unlike for primitive types like number or numref, when we set the value of something, when we set array to be like 1, 2, 3 in this case, what we say is that we want to store the value of an address, which stores our object 1, 2, 3. So likewise, when we do number copy equals number or array ref equals to array, what we can see is that we take the value associated with array and we change array reference to be equal to that value. And like we said before, the big thing about the const keyword is that you cannot change the value that's associated with a variable if you declare it as const. And what we did is that when we said array index 0 to be from 1 to 10, what we said was that we wanted to change the value of array index 0 at address 1. However, what we can see is that we were able to change the value of array, to change the value of the object array points to within the address, but we did not change the value itself. So this means that we were actually able to make array constant, but still change the value of the address that's associated with it. And that also explains why when we change the first index to be 1023, we see that array reference also changed because it pointed to the same address that's stored within array. That was a lot of info dump at once, but does anyone have any questions on how exactly this example worked with an array and how like different references work in JavaScript? All right. In that case, let's say that you want to use something that's like saying, oh, I want numbers copy to actually be a copy of numbers that is different than numbers itself. If I change the value of numbers, I want numbers copy to be completely separate. Well, the way you can do that is actually through something called the spread operator. And let's see what the spread operator does. Instead of doing numbers copy to be equal to numbers, what we can do is that we can use the spread operator, which was introduced in 2015 in JavaScript. And let's see what this does with a ... and numbers inside of an array. And if we run our code, we see that before, when we changed numbers index 0 to be 10, both numbers and numbers copy changed. However, if we run this code that's updated now, we can see that numbers index 0 has changed to 10, but numbers copy is still 1, 2, 3. And to see how this works, we can take a look at the spread operator inside memory. And this is an example of what the spread operator does. When we made our array of numbers, what we did was that we took the value and we made it point to an address of 1, 2, 3. And previously, when you just do equals for the numbers array, we just took the value of the address and threw it into array reference. However, in our case, what we did with this is that we took the address that was stored in 001, and we took all the values of that array, and we made a completely new array, which was a copy of those values. So this means that we were able to completely separate the numbers array or the numbers copy from the previous value, and we actually made a completely new array inside memory. And this concept of separating different types of memories, separate types of data, and making copies is actually really essential when working in React and JavaScript. So if you guys have any questions on the spread operator, or if you have any questions on like the difference between copying things with the equality operator and with the spread operator. All right, and one more thing to note is that there's actually a difference between when we made numbers copy equals numbers and numbers copy equals the spread operator numbers. And the difference between those is actually called deep versus shallow copying. In the first case, when we made array ref equal to array, this was a shallow copy because it points to the same address in memory. However, with the spread operator, this was actually deep copying because instead of pointing to the same address, you made a completely new copy of it, or as it says, a deep copy of the values. All right, perfect. So now that we talked a little bit about objects in JavaScript, now we can see something that really makes JavaScript separate from other different programming languages. And that's the concept of functions. And if you made a function before, this might look a little similar and also a little different. So first, let's keep an example of a variable, like let my var equal hello. And now let's make a function. And let's call it greet. And it'd be like, oh, console.log, hello there. Similarly to how we made variables inside of JavaScript before, does anyone see anything interesting with the way that we made a function inside JavaScript here, or different from other programming languages? Well, in other, oh, sorry.
I was just going to say, all you put in front is function.
Yeah, like in other programming languages like C or C++, you'd say like if you don't return anything, you have to say the return type of the function, like void greet and so forth. And what we can see here is that inside JavaScript, you don't have to declare the type of your function, that return type. And you can simply just call the word function and it knows everything else. All right. And now let's try saying that instead of just greeting anyone, let's say that we want to greet a specific person, passing in parameters. And we can do that by adding a parameter like so. And what we can see is that we don't need to add the type of our parameter as well. And if you wanted to add this into our code, you can just be like, hello there, plus person. And then let's say exclamation mark. And if we try greeting our person, like let's say we want to greet Advaith. And if we run our code, we can see that we can, it says hello there to Advaith. So this is a little bit about, about some of the basics of functions in JavaScript. And something that's also really cool is that, like, let's say you want to see what is the type of the function greet. And let's see what it says. It says that our function is here, a function. And this is actually different because inside JavaScript, functions are first-class functions, which means that they are objects and they can be passed around in a bunch of different ways. Like, for instance, what if we had an array of people? Like, let's say I'm going to make an array of people right here. And let's say it's going to be Advaith, Amanda, and Sid. What first-class functions allow us to do in JavaScript is that if we want to do something with that array, like people.forEach, which is something that we can go into. And I'm going to introduce a little bit of syntax here, but let's go and see what it is in a bit. So for each person within our array of people, let's say that we want to greet that person. And then make this greet. And let's pop this into another function, which is going to be called greet everyone, which is going to take in an array of people to greet and take in a function to greet people with. Or let's change this to be a greeter so that we can make the name different from everything. And let's see if we greet everyone with the people function. Let's see what happens. So we have we have our greeter function and we have our people array that we can pass in. Like, let's call this people R. And what if we want to greet everyone with our people array and our greeter function called greet? Let's see what will happen. Let me remove the other console.logs real quick. And let's see. It says there, hello there, Advaith, Amanda, and Sid. So what we can see is that by breaking down, first, let's break down this example. What we see is that we are able to pass in our people array and a greeter function that we wanted to greet everyone with. What this shows is that in JavaScript, we can pass in functions as parameters to other functions, or we can treat it as like any other object in JavaScript, which is really cool. Like a lot of other languages don't let us have this feature. And this can be really powerful for making function factories, kind of like what we have here. And another thing to note is, let's see what this syntax is here of people.forEach. Well, for each is something within JavaScript that says for each element of an array, you want to do something to it. And this syntax of having a person set of parentheses followed by an equals and that is called an arrow function. And an arrow function is actually just a fancy way of saying, oh, there's a function that I want to make and I want to not name it and just plop it in somewhere. And back to the topic of first-class functions, what the people.forEach function does in JavaScript is that it takes in a function itself in order to do everything to an array. So that might be a bit confusing. So let's try breaking this down to something else. Let's say we wanted to do a greet function, greet individual, which takes in a person and a greeter function. So greet individual is going to, greet individual, people, person, and greeter function. So what we're going to do is that it would be like, okay, let us do that. Let's see, greet the person. So because we need the greeter function from up above, I'm going to plop this inside of the side here. Like, let's make our function called greet individual. And let's say that instead of doing people.forEach with this anonymous arrow function, we can plop in our greet everyone function. Greet or greet everyone. And does it do the same thing? Let's check. People.forEach is not a function. Let's see what has happened. Oh, this should be greet individual. My bad. And we can see that instead of having to make our own function of greet individual here, what an anonymous arrow function does of passing in the parameter of our function, naming it whatever we want, adding an arrow and a brackets of saying what we want to do. This makes it a lot easier for us because it means that we don't have to add the boilerplate of having to name a function if we only use it a single time. Does anyone have any questions on something we covered based off of functions, anonymous arrow functions, and the syntax overall?
Wait, I think this is wait, for greeter, is it supposed to be greet or greeter, or like can you just name it whatever function you want?
All right. So like thank you for catching that. So you saw that here with the greeter person, it still worked even if we called greet person, right? And the reason for that is because within JavaScript, what we have to see is that what is the scope of everything? And we can see that inside greet everyone, if we called it greeter, it would use the parameter that we passed in, which would be greet, like so. However, because we defined the function greet to be in our global scope, or by global scope, I mean, it's not inside of a pair of brackets. It means that anything inside our file here can use the greet function. So in this case, using greet person still worked. However, later down the line, if we're using like a complex JavaScript application, and if greet was inside of a different function or if a different file or a library, for instance, then it would not work. So in this case, if we wanted to do the intended behavior of having our greet everyone function take in people and a greeter function, then this means that we want to use greeter inside of our function like so, because we don't want to use the function that's globally, but we want to use the function that's passed in. If that kind of makes sense.
Yep, thanks.
All right, sounds good. And so this was a lot about JavaScript. And so now that we've talked a bit about like what exactly JavaScript is, let's see how it can be used inside of our code and how this can relate to making websites. And we're going to do a really simple example of making an interactive website. And later down the line, Advait is going to show how we can make this so much easier with React. So in that case, let's go back to our example. And let's say we want our page to have a count that says, you have clicked me 0 times. Then let's have something that says click me in a button. And let's see what it looks like inside of our page. If we refresh, it says you have clicked me 0 times. And if we click, we see that nothing happens yet. So in that case, let's add a bit of JavaScript to our application in order to make it work. And the way you can insert JavaScript into your application can be done multiple ways. Some, like you can use a script tag, and you can also put this into scripts.js. In this case, let's try adding a script tag, and then we'll go from there and see how we can add it to scripts.js. So first, we have to, what we want to do in our JavaScript application is that we want to be able to change the value of this to dynamically change every time you press the button. So a way that we can do that is that first, let's give an ID to the span, which contains the number of times you clicked. Let's say this is a click counter. And within our JavaScript, we can say that click counter equals document dot get element by ID click counter. And the document is something that the browser uses in order to like go through the HTML DOM and grab everything. So document.getElement by ID returns us this span here. And then let's make a function for our button to do something whenever it's clicked. We want to increment our counter. So let's make our function. Let's call this increment likes or increment clicks. Increment clicks. And what increment clicks will do was that first we'll get our click counter. So let's get our click counter here. And then we want to get times clicked equal click counter clicked dot inner HTML. And because JavaScript is funky and we have to get languages for things and we have to get types for things, we have to make a number. And then whenever it's clicked, what we want to do is that we want to set the inner HTML of our click counter to be times clicked plus 1. And we want to add this to our button. And let's see how we can do that. We can do button.add. Let me see what the exact syntax is here. Is it add event listener? Oh no, const button equals. And we want to grab it. And the way we can grab it is like last time, let's make an ID. Call this clicker button. And we can say const button equals document dot get element by ID clicker button. And we want to add an event listener to it. Add event listener, and we want to listen to a click event. So let's see. Click. And whenever it clicks, we want to increment the click counter. And let's see if we run our code, what exactly happens. We can see that every time we click the button, what happens is that the times we've clicked counter increments up by 1. And the way we can do that, like last time, let's take a look, is that, one sec. What we've done is that we've gotten our code here, and we say that we have our click counter here. It says you have clicked me, starts off at 0 times. And we say that every time you click this button, we want to increment it to go up by 1. And a little challenge, if you're curious, is that you can try making a button to decrement the number of times this appears, from going from like 3 to 4, back from 4, 3, 2, 1, back to 0, the different button, and with on click. So this is a little example of how we can use JavaScript to make things interactive. And do you guys have any questions on how exactly we made this work?
So the add event listener and then with the click thing, that's like built in, right? We didn't like create that.
Exactly. Similar to like the document.getElement by ID. So the document is something that's given to us by the browser within JavaScript. And since the document is made by the browser, the button is also something that is created. And as you can see here, by hovering over it, it says we have an HTML element. And for an HTML element, we can actually do a lot of things. Like if you do button dot, you can see a whole slew of things you can do with a HTML element. And in our case, what we said is that we added in event listener that says, whenever this button gets clicked, I want to fire this function. And if you guys want to do some practice with arrow functions, again, I challenge you to try being like, okay, instead of making a different function called increment clicks here, how can I make an arrow function to do the exact same thing? If you want to, you can try doing that, and pretty fun. All right. In that case, do you have any more questions on how we got this to work? All right. So I guess since you have some extra time, let's go add this into our scripts file instead and see how we, instead of adding it into our script directly, we can also add this into a separate JS file and load that in. So let's do that. Instead of adding it into a script tag here, we can make another JS file and call it like button.js. And let's just copy and paste everything inside our script and just slap it in there. Button.js. And instead of putting everything into our script here, we can just say script source equals button.js. And we can see that it has the exact same outcome. If we go here and it goes up like before. So, and as you can see, just doing a simple thing like adding a button to go up 0, 1, 2, 3, 4 each time, it's a whole process of trying to go through the document, get the element by ID, having to add IDs to elements in order to just simply add a button to go up by 1 each time. After the break, Advait is going to show the exact same thing in React and how much easier it can be and the differences between writing an application in plain JavaScript and plain React. In that case, let's take a 5-minute break and we'll be back in 5 minutes. I'll pause the recording.
Okay, so the next thing we're going to learn is how to use React. So first off, what's React? Well, it's a library that runs on top of JavaScript to build user interfaces. It's declarative, component-based, and learn once, write anywhere, which sounds fancy, but it basically means declarative is your code describes what it does. Component-based means that your code is compartmentalized into components, and learn once, write anywhere means adding additional features is easy. But why is React so popular? So there are a lot of other libraries out there like Vue, Angular, Svelte, but React is really, really popular, mainly because of one specific feature. It only updates what needs to be updated, which means if you have like a huge project that runs a lot of data, every time a new piece of data comes in, you don't have to rerun and reload the entire website. It only reloads the specific part which that piece of data changes. Also, React is built by Facebook and it's open source and it has a huge community of users, which also helps make it pretty popular. To start a React app, we use this tool called Create React App, and it's a tool made by Facebook that sets up an NPM package with all the scripts, the dependencies, and a sample app to get started. So we're going to start off with running that. Let's just say npx create app. Also, is the text visible or should I make it bigger? I'm going to make it bigger. That works. So let's create a React app and let's call it example. And as you can see, it's going to take a few seconds and then it's going to create a new React app. So while that runs, let's talk about what commands you do once you start a React app. So when you have a React app, you can install all the dependencies you need using a command called yarn install. You can start the project by doing yarn start. You can build the project to actually deploy it using yarn build when you're deploying in production. And you can run any tests you've written with yarn test. You can also do that with npm or node package manager. And that's using npm install, npm start, npm build, and npm test. So let's hopefully it's still running. Let's wait a few minutes. Any questions so far? Nope. Okay. So once that finishes running, we can change directory into examples. And okay, it's almost done. We can change directly into examples, and we can actually start to see the page that looks like something. So I did not realize it would take this long. Okay, cd example ls, and there's a bunch of files it's made, and let's do yarn start. And that opens this page, which is localhost 3000. And localhost 3000 is the server in which your app is currently deployed. So that's exactly what you're going to get every time you do create React app. Let's start off by trying to understand exactly what the code is. So the website tells us to edit src/.js and save to reload. So we might as well do exactly that. So src app.js. Okay, so you can see what React wants us to edit here, right? Before we do that, is there anything you notice here that's quite different from JavaScript, or anything you're curious about or you think is cool before I actually explain everything on it? Any questions? Or no? Okay. So one cool thing that you notice is you can import files, whether they're CSS or PNGs or pretty much anything. And you can import them under a different name and also use them as a different name. So we import logo.svg here as logo, and then we just use it. And some of our HTML properties have a different name now. So instead of class, we have class name. And when I hover over this, you see something that it says JSX attribute, class name string. And this is one of React's amazing parts. It basically means JavaScript inside HTML, which is what JSX does. So let's start off by adding one tag and adding a h1 tag. So let me just add an h1 here and say hello. Okay, well, that's pretty straightforward, right? But we can also do that by making a variable instead. So using the good old const we just learned, let's say greeting, hello. And well, now we want that greeting to show up here. And the way you do this in JavaScript is you'd have the ID for h1, and then you'd say document.getElement by ID inner HTML is equal to greeting. The way you do it in React is you do that. And let's check if it worked. Hello. So this is one of the coolest parts about React is that you can use JavaScript within normal HTML code. And that makes it really cool. You can also do this with functions. Okay, let's write a normal function that takes in something and return extra. And it takes in the parameter as greeting. That should work. There we go. So I just wrote a function inside HTML. Sorry for the confusion. I'm not really sure why that didn't work, but I will look into it later. So that's one cool thing you can do. You can write functions within your HTML code to make it work. Anyway, other than that, there's also other things that change from HTML to React. And one example is class becoming class name. And the typical change is everything that is a DOM element name becomes camel case. So on change becomes on change, but the C becomes capitalized. Okay. The next thing we're going to talk about is something called state. And this is another really cool feature of React. And state is essentially similar to having your member variables within a component. And to do that, we use something called useState. So, oh no, that's not it. I do not remember. Okay, I really should have prepared better for this. What's the use state import?
Let's see, import React, comma, and then the bracket use state.
Oh yeah. Okay, anyway. So we've imported use state, which allows us to use the concept of state. And to do that, we use this syntax. Let's just say number, set number is equal to use state. Oh, that's in the 1 second. Okay, so anyway, what I'm doing right now is using the concept of state to create a variable called number and create a function called set number that allows you to change that number. And that's basically what use state does. Is it creates a variable within your component and allows you to use a function to change that variable. Another really cool part of React is what's called props. So to do this, I'm just going to go back to the thing and use existing code. But yeah, so props is the original input that you pass into a function in React. If you look at this function, for example, function cat prop return div prop.name. And then in the app, you have an array called cat, and then you map it to the cat's component with the prop, the name being cat. And I know that looks confusing, so I'm going to explain that in more detail. So app is a function that you already saw, and we're having, well, cats here, which is a constant array that we're creating, and number, which is a state variable that we're creating with the function set number. And what app returns is this whole division with the header with map, which takes an array and maps every single element in that array to the function that's within its brackets. So in this case, it's mapping everything in cats with the label cat into the component cats with the prop name being cat. So every single cat in this, let's say pickles, goes into this component named cats with name equal to cat, name equal to pickles in this case. And then this function takes the props, which in this case is name equal to pickles, and returns a div with pickles in it. And that happens to every single cat in this array. And that returns the array. Any questions? No? Okay. So props are basically similar to the constructor variables in C++, because you can pass them into the function. And state is like the member variables in C++. You can't really modify state directly. You have to use set state, which is the function you have with state, in order to actually change the state. And this is because one of the cool features of React, which we talked about in the beginning, was how React only changes the parts of your page that need to be changed. And to do that, one thing it uses is state. So when a state that's used somewhere in the page is changed using a set state function, React re-renders that part of the page. So let's look at this code. And I'm just going to copy paste this in so we can look at the output as well. Okay. Now, what this code does is it has cats as well as, well, it counts the number of cats. So let's go back to our localhost, and this is the result. When you do that, it increments. And this is again similar to the code you did in JavaScript, but much, much more straightforward. So again, it maps each cat to the cats component with the props name equal to cat, which is what you saw already. But this one now returns a div with the name, the number, which is a state within the component, and a button which on click sets the number to number plus 1. Does that make sense? No, okay. No questions. Okay. Yeah. So the way this is working is it's using the state. So each individual cat's object has its own number, and it sets that number using this function here whenever you click on it to the number plus 1, and it's initialized to 0 within the use state. Okay. React in the past used to be more based on classes, and it's currently getting phased out. Everything we've seen so far is functional React, which uses states and props. Before, it was quite different. It used a constructor, and it used component did mount and component will unmount to do things when a component started and when a component is deleted. So the reason functional is better is because it's lightweight, it's easier to read, and it has stuff like use state, which is really cool. So it's practically the default. Did I miss something? This feels really quick. Okay. Anyway. Finally, manipulating the DOM in React. So in the beginning, we made the whole JavaScript, well, code, which takes the counter and increments the button, right? So let's remake the exact same thing in React again. And you've practically already seen this with the number and use number thing. So let's start with that. Const count set count is equal to use state 0. And let's say a paragraph with the current value of count, which is the current number. And then let's, oh my God, I should have disabled Copilot before this. But a button which on click sets the count to be count +1. And that gives us the exact same website we had in JavaScript, but a lot simpler and a lot shorter, I guess, because you can straight up use the JavaScript within the component itself. Does that make sense? Any questions? No? Okay. Well, that's basically most of what we had on React. So is there anything you want to add, Matt?
No, I think that was good. So
Okay.
today we talked a little bit about JavaScript and React and got a taste of how we can make interactive websites by using JavaScript and React within our web apps. Next week, we'll go into a little more detail about like some more things you can do in React, as well as some problems with JavaScript and how we can use TypeScript to fix them in the future. So stay tuned, and we hope to see you guys again next week.